We are working on integrated rate laws, and we're doing a graphical test to determine the order. And so this is the data that we have, and I want to show you how we can use Excel to do some of our graphing and our mathematics for us. Now, you did this on your last lab, and I was under the impression from past experience that you were familiar with a few things. One, that you knew how to use Excel a little bit at least to do a graph. And secondly, that you knew what this R² was, that you knew that it was a correlation coefficient. And what that correlation coefficient means is our goal is to get that as close to the number 1 as possible. The closer it is to 1, then they don't like that formula that I just put in. So the closer that is to 1, the better our data correlates with or matches or aligns with the straight line. So we're going to do a couple of quick graphs with that. Now, we saw before that if we graph time directly versus concentration, this would be a test for zero order. So we're going to highlight the data that we want, and then we're going to click on charts. Now, mine's a little bit different because I'm on a Macintosh, but it's a very similar concept. When you get to charts, you want to choose scatter. I can't think of a time we're not going to use a scatter plot, and we never connect the dots. We're going to let our trend line do that for us. So here's the line that we get. Possibly by inspection, you would say, hey, this is not a straight line. It can't be zero order, but remember, we're talking about experimental data, and we want to look at the numerical statistics. Looking at it visually is fine, but we need the numerical statistics. So you right-click on any point and go down to say Add Trend Line. And I'm not going to put in axes and titles and everything. I'm just trying to make a point here. Obviously, I would expect you to do that. When you say add trend line, it says automatic here. And way down at the bottom on a PC, this is a little bit longer of a little menu here. And I click display the equation on the chart because we'll need that. And display the R², that correlation coefficient. Now, some of you may think, and I had this the last time, they're like, wow, 0.93, that's really close to 1. But I think you can see by looking at the data that it's visually not very close to 1. So let's go ahead and put in the data we get from this one. This is -2 times 10 to the -5th for our slope. And our R² is 0.93085. Now, this is what you're going to be doing for your crystal violet. You've probably already got the data. I had you do that, but now we're going to analyze the data, and I hope you'll understand it a little better. Okay, so that was our zero order test. Okay, so let's get rid of that graph, and let's type in really big here so you know for sure what we're talking about. We've got a zero order test. Now, to do the first order test, we have to take the natural log. So in Excel, you put in an equal sign to tell it you're about to enter a mathematical formula. And I want to type in ln for natural log. It wants parentheses around the value. And I'm going to click on the cell that I want to take the natural log of the number that's in that cell. And don't forget to close your parens. And I hit enter. Now, here's what's nice. Yes, you have to show me with a setup completely worked out one of every type of calculation, but you don't have to show me repetitive calculations. So, bam, you do that and Excel does it for you. Let's try that again. Do you see this little box here? You can grab that box and drag it down and it cuts and pastes. Now you notice that this number here was to this D2 cell. Well, once I did this, it advanced the cells each time. So if you notice right here, it went from D3 to D4 and so forth. You can also do cut and paste if you want. I just wanted to show you a quick way. I was watching students do that before and I'm like, really threw me. And it's like, I want to do that because that's very fast. Again, go to charts, scatter plot. Now, this one, I would definitely expect you to fix your scales on this. We don't want the x-axis up at the top, and we want our data spread as much as we can over this. And the reason is because looking at this, it kind of looks like it's a straight line. In fact, I'm going to do that for you because I think it'll demonstrate something. I'm going to format the axes, and instead of having it go to 0 here, I'm going to start it at -4. I'm going to spread out the data, and you see when you spread out the data that the curve becomes a little bit more evident. When you squish data together, you can obscure what the data trend is telling you. So I'm going to go down to add my trend line, options. In a PC, you don't have to click the options. That's a Macintosh issue. Get your equation, get your R squared. So now I have that data. Well, certainly 0.98 is much better than 0.93, but we still haven't ruled out second. So we can't make any conclusions until we test it all. The slope is negative, 0.0032. And our R squared is 0.98224. Whoops, I think I messed that up. So enter that, and our R squared is 0.98224. Okay, now get rid of that graph. That was, remember, our first order test. And right now, if we had to pick between these two, even given experimental error, we saw that on the last one, the R squared wasn't so good because you were just learning how to use pipettes. But certainly I'd choose first order over 0 order, but we're not done yet. So let's try our second order. Put in the equals to tell it's a formula. I want to take 1 divided by my original concentration. Okay, and then you can cut and paste or drag, grab and drag, or cut and paste, it doesn't matter. And let's get our scatter plot. Now in your lab, you're going to have titles and axes labeled and all of that stuff. I simply don't want to waste your time. This looks pretty good to me. This looks like a nice straight line, but we don't rely on visual comparison. We want to look at the statistical comparison. And that's why we want that R squared, because that will statistically tell me how well do my data points align with a straight line for this particular curve. So when we graph, let's move it over here, 1 over the concentration versus time, look at that. The correlation coefficient is 0.99982. Okay, I think we have a winner, 0.5475. Now, you have tables of this. So if you look at the top of page 9, you have tables to be entering this data. And so you want to make sure you enter this data into those tables so that when you go back and look at it, you'll see that we came to the conclusion based on our test that this was second order with respect to our NO2, our concentration of our NO2. Okay, so that would be our final conclusion. So that's the winner. Now, because we have that, and let's take a look at this, we're going to now ignore this data. I mean, our original data is great. We don't want to delete it. You've got to have your original data there. But for analysis purposes, we're now going to set that data aside. It's just not useful to us anymore because it was the second order, that turned out to be the correct order. Now, when it's third order, we can get our K value. So you won't have a value for K for those other two because they're not valid data points. So here we would find that our rate constant K, lowercase, very carefully, very key, uppercase is an equilibrium constant. It must be lowercase, is equal to the slope. So our K is equal to 0.5475. 0.475. Now, the units would be our time, so that would be seconds to the -1. And assuming that this was the only substance here, we would put molarity to the minus 2 minus 1, so it'd be -1. Now, we don't really know the overall order in terms of the other substances present. So, but I just want to take a minute and practice that if we could. Now,